I welcome everyone today. I'm Keith Gillis. I'm the Dean Emeritus of the Rausser College of Natural Resources. And at the same time, I'm also chair of the California Board of Forestry and Fire Protection. I'd like to thank everybody that has joined us today for your interest in our programs in the College of Research, Teaching, and Outreach. And thank you as well to all of you that are donors for your continued and future support for the campus and for the college in what are both challenging but also very exciting times for Berkeley. I'm really pleased to be able to introduce my colleague today, Scott Stevens. And Scott is a professor of fire science in the Department of Environmental Science, Policy, and Management. Scott is a leading expert. Some would say the leading expert. I'd actually say probably the leading expert in the solar system on the issue of fire science. He's the director of the UC Berkeley Center for Fire Research and Outreach. His research expertise and program spans fire management, forest ecosystems, and fire ecology. He works a great deal on the interactions of wildland fire and ecosystems, including how prehistoric fires interacted with those ecosystems, how current wildland fires are affecting our ecosystems, how future fires, changing climates and management are going to change those interactions. Scott, given his background originally in engineering and then in fire science, has always impressed me, given my background in the economics of forestry, for how adeptly he spans the link between science and policy, where he has been an outstanding contributor to the national rhetoric and interaction about the role of fire and what good fire policy would be for the country. Both in the United States and internationally. And with that, I will pass to Scott. And Scott, I look very much forward to hearing what you have to say to us today.
Well, thank you, Keith, for the very nice introduction. And hello, everybody. I know we're doing this virtually, but it is still a very cool homecoming for Berkeley. And I hope to be able to generate some questions that you could ask me. So you can ask me some questions about my talk. Here, I'll start it up. So this idea of fire in California and kind of some of the connections to so many issues. And of course, this year is the year all of us have kind of direct experience with fire in the state. Many of us have certainly had it for many years. All the smoke this year, all the impacts of all the lightning fires that started in mid-August. One thing I'd like to say up front is I bet you there are people on this Zoom that actually are impacted by the fires, could have lost a home, could have lost even a loved one, certainly friends, relatives, others that had impact. So I just want to recognize that out the bat. It turns out one of my best friends lost their house in the Hennessy fire this year. So I know fire has impacted a lot of people. I just want to say I know it is difficult. And I'm going to try to give a perspective today that might show some of the other aspects of fire. Here in this picture I start with, there's Jason Mogadas, one of our alums, and we're burning a prescribed fire at University of California Blodgett Forest Research Station. So we're actually putting fire on the ground for a management purpose. You can see it's night. Jason's got a drip torch in his hand, and we're burning through this mixed conifer forest. And we'll certainly talk about this some more. Before we begin, I'd like to take a moment to kind of connect to something in the past. Here we got 1956. The 1956 National Geographic, our green treasury, the national forest, Nathaniel Kenny. So it's a very interesting piece. When you read this, it really talks about the treasure of the national forest system, how this is going to be used by all the people of the United States. It really focuses heavily on the idea that science and technology are going to solve all the problems of conservation. I find that to be a very interesting premise. And when I look back on this now, I could see maybe in the 50s and 60s, this was something that was going to come forward. I would just say my view is that science and technology is going to assist us, but it's more fundamental than that. It's really about people and land. And science and technology is not going to solve all of our fire problems. Far from it, frankly. And I'll show you some of that in a moment. Here's a quote from Nathaniel Kenny, 1956. As one fire expert told me, I don't believe that equipment and development alone will show us how to not keep having the relatively few big fires. Researchers must let their imagination soar for answers that today would seem fantastic. Isn't that amazing? 1956, we could put 2020 on that because we're still wondering about fire. What do we do? How do we manage it? And here we see in 1956, someone's asking the same question. And certainly it was asked even before that. But this question's been going on for decades and decades and decades, okay? So I just want to give us a sense. And we're going to come back to Nathaniel Kenny's question at the end of my talk. One thing I'd like to talk about with you is this idea of fire in Native communities in California. Here we see Val Lopez. Val is actually the chairman of the Ama Mutsun tribal band. The Ama Mutsun tribal band home territory goes from Santa Cruz down to Monterey Bay and goes inland to Pinnacles National Monument. So that's their tribal territory. And Val is the leader of the Ama Mutsun. We've had the pleasure to work with him on some ideas of restoration of cultural burning. And one thing Val says that blows my mind a little bit, frankly, is that quote there at the bottom. Fire is a gift from Creator for the stewardship of the land. Think about that. Just think about that. Here, the Ama Mutsun, who have lived in what we call California today for thousands and thousands of years, and they think of fire as a gift from Creator for the stewardship of the land. And this is a perspective, I think, in many ways we could actually learn from. And I'm not saying this is simple or that it's easy to do, but this idea of fire being useful in stewardship and actually a gift. I find that to be just really, really interesting, and also something that is a perspective that is quite different from a Western perspective, a Western science perspective. The next slide kind of shows maybe a little bit more of the perspective we see more common. I took this picture a few years ago in the foothills of the Sierra Nevada. I'd come out and, you know, this is an amazing, beautiful sign. Firefighters are heroes. And they are, because firefighting is incredibly dangerous. It's also a very, very difficult profession. This year, with all the fires happening in California, I think at one time we had 14,000 firefighters working in this state. And of course, when firefighters are working, they're trying to keep fire from damaging people's homes, damaging people's lives, keeping people alive. So you get this outpouring, of course, of thanking them. And I've seen signs like this all over lately in the Napa Valley, around Santa Cruz, in the Sierra Nevada. So we get these kind of incredible, you know, outpourings of thanks to firefighters as the heroes. I would just say, yes, they are heroes and they are incredibly important. I did a little firefighting earlier in my career. It's a very, very difficult job. But when we think of fire in this context, it just has a different dynamic, isn't it? It's more about we're always trying to eliminate fire. It's always damaging. It's always hurtful. And I'm not saying that firefighters say that, but that's just kind of our philosophy, I think, with fire in most of the state. Contrast that to what Val Lopez said, that fire is a gift from Creator for the stewardship of the land. I want to spend a moment to talk about kind of some evidence of forests in California and how they were observed early in the 1920s. Here's a picture actually of the Bear Creek Guard Station, 1915. The Bear Creek Guard Station was built in an area in the Plumas National Forest right above our forestry summer camp. Forestry Summer Camp is one of our rich traditions of Berkeley forestry, just a magnificent institution. Over 100 years now, we've been teaching foresters in our Forestry Summer Camp in Meadow Valley. This is just up the mountain from that. Forest Service is created in 1905, so this is built just 10 years later. So the guard station is put there for a guard, a forest guard, to patrol the forest for unauthorized timber harvest, also to begin to suppress fires. And you look at that forest, look at its character. You see some big ponderosa pines, beautiful trees. You see low shrubs in the understory. You see a snag in the background to the left. And this is the forest character of 1915 in the Sierra Nevada in the northern area. And here's some quotes from Shao and Kotok. Shao and Kotok were some of the earliest fire researchers in California, and they were very prominent in what they basically were able to do, and their policies were incredibly followed. So here's some quotes from 1924. California pine forests represent broken, patchy, understocked stands worn down by the attrition of repeated fires. Extensive crown fires are almost unknown to the California pine region. The virgin forest, subjected to repeated surface fires for centuries, has been exposed to cumulative risk. And when we look at the fire intervals that were burning during this time, and we can get this from tree ring records, we're looking at fires maybe every 7 to 15 years or so. And this is going to be both from lightning ignitions and also indigenous burning. And the idea of understock needs to be maybe explored a little bit. Understock simply is the idea there are fewer trees per acre than potentially there could be. And the Forest Service was interested in generating revenue, generating saw logs for the American public. So they thought that we could actually remove that fire and then actually get more tree regeneration, increase the stocking, the number of trees per acre, and then inevitably grow more wood for the California and the US public. So this is what kind of Shao and Kotak are telling us, that it's understocked, fire's been damaging this ecosystem, we need to remove it, and we can then therefore maybe achieve some more of our goals. Very interesting perspective. Quick summary of fire suppression. So fire suppression is simply the organized policy and resources from government to try to remove fire from ecosystems. It starts in California around 1905. It starts a little bit different times in different regions. The more remote areas, say of the Klamath Mountains and the northwestern part of the state, starts maybe 1920. Starts a little earlier in other regions, but 1905 is general era of fire suppression begins. If we look at the number of fires we have each year in the United States in wildlands, not in urban areas, but in forests, grasslands, and also shrublands, it's around 80,000 fires a year. Sometimes a little bit more, sometimes a little less. That's a large number of fires, of course, and it depends where we are on ignition source. If we're in coastal California, primarily people are ignitions. Of course, this year is a difference because this year we had all those lightning fires. If we go to more remote areas, lightning fire is still the dominant ignition type. But one thing that we have today, 98 to 99% of all wildfires are put out less than 5 acres in size. That's an extraordinary statistic. 98 to 99%, all fires are put out less than 5 acres in size. That requires an incredibly trained workforce, very mobile, early detection, get people on fires early when they have the opportunity, try to get them out small, and then therefore be successful. 98 to 99%, you got to say that's an amazing success from a statistical standpoint. But the conundrum is that 95% of the area burned today is from the 1 to 2% of the fires that escape initial attack. So we get a few fires that generate big area. And that really does have ramifications for California. Before 1800, we estimated from fire literature, from fire-scarred records on trees, and also from indigenous burning practices, we estimated about 4.5 million acres burned annually in California on an average year. That number is actually a conservative estimate. We also have another estimate in that paper that's 3 times higher, about 12 million acres a year. But the 4.5 million is one that's been talked about in a policy setting. So it's a relatively large area, of course. And lightning and indigenous burnings were common. Half of that area, at least, was from indigenous burning by tribes of California for things like food, for fiber production, for medicines, spiritual. Also, they burned around their communities to try to reduce risk. So half of that area, 4.5 million acres, was likely burned by indigenous people. Today, I would say in most cases, we burn around 10 to 40% of that area in an average year, but not in 2020. I saw the statistics this morning. I think we're up to 4.1 million acres burned this year. That is extraordinary. And it's actually a number that is really large compared to what's been just in the last 10 years. So I would imagine, just based on our fire season, which isn't over yet, we're probably going to approach that 4.5 million acres for the first time in our history. That alone is an extraordinary event. You know, all those lightning fires, 360 simultaneous within 48 hours. There isn't a single system in the world that can deal with that many fires so spread out over such terrain and actually not really be a bit overwhelmed, even though we have the best fire management, fire suppression organization in the entire world right here in California. So just a little background again. So when you have fires happening every 10 years, 15 years, 20 years, 5 years from both indigenous and lightning ignition, and we take it out in 1905, what happens? What happens to places like the forest of the Sierra Nevada? And I want to show you some photographs here and some sequences. I hope that might generate some discussion. So we're going to get a little data. And the data we're going to get is in the San Bruno Federal Archive. This is actually a place in San Bruno, California, where data has been archived for a whole bunch of federal agencies. If you go in there and you're lucky, we were able to find some of these forms. This is a form, Form 321A from the USDA, Forest Service. And if you look maybe on the top, you might be able to see the date, 7/8/1911. This is an inventory form of 1911 of the first inventory of the Stanislaus National Forest. In here we have size on the left. You see 12, 14, 16, 18. Those are diameters of the trees. And then we have on top species, yellow pine, which is ponderosa Jeffrey pine, sugar pine, SP, WF white fir. So this is actually a tally of the forest composition and size in 1911. Extraordinary data, frankly. This data is actually connected to our public land survey system, section corners. Those section corners are still there today. So you can actually go out here and do some remeasurement and try to compare what we see in 1911 from the first forest inventory in the Sierra Nevada Stanislaus National Forest and also parts of Yosemite National Park. And we've done that. Here are just a couple places you see in the map. We did it in the Stanislaus and Yosemite. We've also done it in a place called the Kern National Forest, which is now today called the Sequoia National Forest. And the thing I wanted to show you there, this is a lot of data. You're talking about records of about 20,000 trees that encompass tens of thousands of acres. So you're not talking about a 100-acre spot or a 500-acre spot. You're talking about a landscape assessment. This is a big area of data that we were able to basically get from the archive. Here's a summary slide of what that data tells us and also our remeasurement that we did in 2013. So the picture on the left is actually a photograph from that era of 1911. Mixed conifer forest, just a little bit like the Bear Creek Guard Station we saw a moment ago, a little higher density, some large trees in there, a lot of open ground. The one on the right, 2013, is actually one of the places we remeasured in that 1911 data set when we were there. So if we look in the two different things, let's look at tree density. Tree density is simply the number of trees per acre. So you're going to count the number of trees per acre and get a sample of that. So trees over 36 inches diameter or 3 feet in diameter, interestingly, the survey shows about the same number over that area of the Stanislaus National Forest. But when we go down to lower size class trees, like 6 inches in diameter or higher, 22 were surveyed in 1911. We got about 100 in 2013. So about a 5 times increase in the smaller sizes if we go back to 6 inches. And over here, this is the proportion of the stands that were pine, 56% in 1911. Pines are actually more adapted to fire. They're more adapted to drought. They're more tolerant of those two factors. And we see that after a number of years, we're down to around 45% pine. So we've seen the pine proportion decrease. I would say this is a very typical assessment of most places in the Sierra Nevada mixed conifer ponderosa pine forest. Increase in forest density. You take fire out. Fire used to thin the forest, used to go in and kill trees, small trees mostly, a few larger ones. So if you had that process of fire burning every 7 to 15 years, you had this amazing agent that was keeping forest density relatively low, like the picture here in 1911. So when we take that out, certainly there are going to be some ramifications. Turned out that in 2013, we were actually out there remeasuring that data that I showed you in the previous slide. Here I am with a few of the students working off one of those section corners, and we're remeasuring the area with, we see a tape here, and we're getting a plot put in, and we're going to measure the diameter of the trees. Turns out there's a large sugar pine log here. We see very high forest density because of fire suppression and also past harvesting that removed big trees and allowed more openings for trees to establish, and then lack of fire allows them to grow and get more dense. But take a look at that picture there in July 2013. Maybe you remember, but there was a big wildfire in 2013, the Rimfire. And lo and behold, the Rimfire burned our plots. So this is actually the same photographic point, but now we're late September 2013 after the Rimfire burn. So we see that log has been burned, certainly. We also see an awful lot of the forest canopy has been killed by the fire. Our trees in the Sierra Nevada take about 2 years for a cone to mature. After 2 years, the cone then will open up, disperse its seed to the ground by wind. Small mammals will collect it, the wind will move it around, and then that seed can regenerate a new forest. The seed has no capacity to stay in the soil for decades or even more than 3 months. So the problem with a fire like this is if we kill the seed sources, the trees, over vast areas, thousands of acres or tens of hundreds of acres, we don't have a local seed source available then for those seeds to come from the mature cones and reforest the site and actually get a forest to continue. If we're in Yellowstone National Park, it's different. Yellowstone has closed cones. After the fire burns, the cones open, the seed drops. We don't have species like that in the Sierra Nevada. So the next slide, this is going to show a few years later, 2013, here's 2016. There's the same log, and we start to see shrubs coming back from the seed bank in the soil. The soil does have seeds from the shrubs. They can be in there and viable for decades and decades. And we also see a bunch of grass. I would say this is the type of fire we're very nervous about in California. The one that basically kills trees over areas continuously for maybe hundreds or thousands of acres, and then the real difficulty of regenerating a forest again. So that's what we're trying to basically manage against. Here's a California black oak that was actually alive barely in 2013. Afterwards, the same fire killed most of the conifers. This oak actually resprouted from the base because hardwoods do have the ability to resprout from the base. The conifers don't. And this turns out to be an incredibly important resource for California tribes in the Sierra Nevada because acorns were a staple of their diet, primarily in the winter. So I think this is a legacy here of actually indigenous management, probably keeping that forested area much more open, allowing the oaks to thrive and not having the conifers overtop them and actually kill them just by low light levels. So what are we going to do about it? What can we do about it? Here we're going to talk about some opportunities. This is a research study that we began in 2001 at our Blodgett Forest Research Station. It's up near Georgetown, California, between Auburn and Placerville, but higher in elevation. So we have 4 different treatments we're going to put into this particular area. One's control. We're not going to do anything except suppress fire for the duration of the study. One, we're going to use mechanical methods to do a restoration treatment to try to reduce potential fire behavior and effects and make the stands and forests more resilient to wildfire and insects and drought. We're going to do a combination of mechanical treatment and then burn afterwards, prescribed fire, like the picture I showed you in my first slide. And then we're also going to do a treatment where we just use prescribed fire alone. We're not going to do any pre-treatment mechanically. These units are all about 50 acres in size, and all of them were basically identical statistically when we started in terms of basal area of trees, tree density, fuel loads, things of that nature. So what do they look like? Now I want to show you some pictures of repeat photography from the last 20 years. So here we are. So we're at Blodgett Forest, mixed conifer forest. Hasn't burned since around 1903. It's had commercial harvesting for many, many decades. You can see possibly the stump down here in the left foreground. And we're going to watch this California black oak upper right. We're going to see that in the pictures I'm going to show you. So we see an awful lot of incense cedar here. These are incense cedar, a shade tolerant species. It's able to grow in heavy shade. We don't see ponderosa pine. We don't see the pines here because they just don't have the microenvironment that allows them to thrive and grow. So the goal now is with the machine is to go in, harvest some of these trees, send them to the sawmill, make lumber. But the trees that are too small, 8 to 10 inches in diameter, we have limited use for them. So what we're going to do with them is we're going to use a machine called a Masticator. Now here's a Masticator. So the Masticator comes in and actually grinds up the smaller trees in place, grinds them up with this big arm with a disc on the end of the arm that has teeth on the bottom that spins around 500 RPM, revolutions per minute. So we're going to go in here and we're actually going to take down those smaller trees after we've actually taken some trees out for restoration. The big deal here is when we do a treatment, we're actually thinking about what do we want to leave? What do we want to leave for the legacy of the forest so it actually will thrive into the future? Larger trees, more pines, more space. And then we take stuff out, but that's actually part of the prescription because we want to leave a legacy and restoration that allows that forest to continue. So the next picture is going to show what the forest looks like. There's that oak, again, that I showed you a moment ago. And you can see, we see residues of the harvest in the picture and also a more open stand. So we've reduced tree density, but we've also taken some of that fuel that was standing up originally, we put it on the ground. So we've added surface fuel by actually reducing ladder fuel. Ladder fuel is actually the fuel that ladders into the vertical canopy. So this is 2003. Let's go forward. Here we are a few years later, and we see all of a sudden that a lot of the understory is starting to develop again, and a lot of the surface fuels that were masticated have already decomposed. This surprised us. Ignacio Chapella, one of our colleagues, came up here and actually identified native fan fungi that actually really efficiently decayed that material the masticator had created. I thought it might stay for decades because, you know, Sierra Nevada is dry in the summer. There's not a lot of water around that actually enables decomposition. But by 6-7 years after our initial treatment, over 80% of that mass was gone. Let's go forward a few more years. So here we see 2015, maybe about 14 years later, we see that understory of incense cedar developing again. So we're seeing the forest continue to develop over time. And then what do? We come in and we actually do a second treatment. We masticate again. We also do a harvest of commercial saw timber. And this is what we see basically today. I'd argue this is quite a positive outcome. Certainly fire hasn't been used, and fire is the natural process, but this basically has created a forest condition that's much more resilient to drought, much more resilient to wildfire, and actually carbon sequestration by these trees is actually doing very, very well if we're interested in sequestering carbon from the atmosphere. Let's look at a couple more examples of the experiment. Now we're going to start another place, and we're going to watch that white fir in the dead center. We're going to do the same mechanical treatment, but then we're going to burn it, mechanical plus fire. So we're going to actually do the combo treatment. So here's the pre-treatment condition. Here's after our first harvest, and you can see there's that white fir dead center. You also see an awful lot of material that's been added to the ground, the surface fuels that are basically still there. We see some more California black oaks in the background, a very important species. It's actually a tree that we try to retain and enhance at Blodgett. What are we going to do next? Well, we're going to burn it. So this is one of my students, Tadashi Moody, actually burning a backing fire at night through this stand to actually consume those surface fuels we just saw a moment ago. So we're burning this at night. We've got a prescription higher humidity. We've got lines cut around the unit, and we're going through and doing a prescribed fire. The next picture shows us the same tree after the first fire. There it is. We see some bark char on it, but we also see incredible removal of the surface fuel. We actually took away about 80%. And that was actually within our objective. Now we're going to go forward a couple of years. 2003, here's a couple of years, and look what the understory, a shrub comes back, a native shrub. This is Ceanothus integerrimus buckbrush. So there's a bunch of seeds in the soil seed bank that actually get stimulated by the burning, and also the lower canopy cover, more light on the ground, and they thrive. The next picture is a few years later. This stuff is 6 feet tall. Trees are growing slowly, but the shrubs are growing really fast. So what do? We decide we're going to come back in. We're going to do the same mastication again. So there's the same tree, and we masticated again the shrubs. We left some pockets of the shrubs for wildlife habitat, and this is the condition after the second mastication. We burn it a second time. So we actually doing a burn. I don't have the same picture of that actual tree here, unfortunately. This is actually a burn in the same general area. And there is the tree that we started with in the beginning after 2 fires and 2 mastications. Take a look at behind. See those brown needles back there? We actually have caused more damage to the residual stand by the burning than we had hoped. And when we look at the tree growth of this particular treatment, we see the trees are growing, but very slowly. And we're not seeing carbon sequestration happening at the rate that we had hoped. But we also see a very, very low fire hazard because of the treatment, very low surface fuels, very low ladder fuels. Let's take a look at one more sequence. Now we're going to do the same treatment, but we're only going to use fire. We're not going to do anything mechanical at all. So here's the beginning treatment. There's a big sugar pine dead center there. You see all that deadened down material. That's around 30 tons of fuel per acre on the surface of the ground of the deadened down wood. Tree density is around 250 trees per acre. So it's very high density. So what are we going to do? We're going to go in here and we're going to do some burning. Okay, we're going to use prescribed fire. Here's a picture of that particular stand burning, not with that exact sugar pine, but this is a night burn. You can see that the trees are torching. And remember, we're using fire here as the agent of forest density reduction. So we want to kill trees. And this is what this prescription's doing. So we're killing the understory. We got some tan oak there to the left. We see white firs torching, a lot of sparks. But we don't have problems per se because the weather's on our side. We have decent relative humidity, low temperatures, modest winds. So what's this stand look like now? There it is. There's that sugar pine. And we see that we've actually consumed the majority of the surface fuel, and we've killed a lot of the smaller trees. The goal was to kill 75% of the trees that were less than 10 inches diameter. We're not doing it with a machine, we're doing it with fire this time. So that's our condition right after the first fire. Let's take a look what happens in a couple years. Well, we get a response from the same shrub. This is our deer brush coming back. We also start to see some of the logs coming down because of just natural processes like decomposition and wind throw. The wind's knocking things down, snowpack. So we see the place is changing. What are we going to do? We're going to burn it again. So here, a few years later, we do a prescribed fire, and I took a picture when we did the ignition right here near that same tree. So this is the second fire. What's the stand look like after the second fire? Here it is. There's that same sugar pine. And you can see more deadened down material. A few shrubs actually live, but we're doing more reduction of forest density. We're burning up the trees that actually got killed previously, and that's after the second fire. What happens now? A few more years ahead. Here we are again with that sugar pine, more shrub development. A few more of the down trees have come down just through natural processes. And what do? We burn it for a third time. So here we are again with the fire ignited with that same sugar pine after all those years, 2017. And this is what it looks like today. So this is the culmination of 3 fires in a forest that hadn't had fire in about 100 years with commercial harvesting in the past. And we're basically in a condition today that's incredibly resilient to fire, climate change, and others. So I would say this is a very desirable outcome. I would say all 3 treatments we just looked at are desirable in terms of moving forests forward in the Sierra Nevada in a warming climate, also higher incidence of ignitions. They're all a little different. Carbon sequestration, invasive species, a few things that are a little different we could talk about, but I think at the end of the day, the research we've shown, we've written 40 papers on this study now. The research has shown from many aspects that we see really good outcomes from these 3 different forest treatments. Well, here's this quick summary of that. And we've talked about most of this. The treatments are basically successful in reducing fire hazards. We're seeing some real increases in resilience of individual trees, particularly the ones in the mechanical only treatment, a little less so in the fire only. The mechanical plus fire treatment has the least resilience. We're causing more damage to those trees in the residual stand. Most ecosystem components measured, including soils, small mammals and birds, vegetation, bark beetles, exhibit almost no impacts negatively. The only thing is we did see a slight increase in non-native herbaceous plants in the mechanical plus fire treatment. A recent study, one done by John Battle's student, actually found that those invasive plants have actually been diminished over 20 years. We need to do these about every 15 to 20 years or so if we want to maintain this site. And one thing about this is so important, the treatments never end. It's a conversation with the land that never ends. This is what we can learn from our predecessors on this land, the indigenous communities. They had this stewardship ethic of the land that actually went on forever. And this is exactly what we have to do. We have to have this connection to the land through restoration, through prescribed burning, through restoration thinning, other ideas too, maybe some livestock grazing and other ideas. But it's a conversation that never ends. It goes on forever. If we just stop, we just see what happens. We get high forest density, we see the resilience decrease. So forest carbon's more stable with the treatments with fire, but lo and behold, the one that actually produces the most carbon sequestration is the mechanical treatment. Actually, the control is doing pretty good too, which is a little bit surprising. What about our implementation? How are we doing in terms of the state of actually getting treatments on the ground to address the issues that we've just talked about for the last few minutes? Here's a figure out of a paper Malcolm North, a colleague from the U.S. Forest Service Research Station, wrote a few years ago, and it's really telling. So over here on the y-axis, we have acres, 3 million, 22,500,000. So this is the acres of land. We're talking about the U.S. Forest Service national forest lands of the Sierra Nevada. So we're talking about just them. We're not talking about private or small non-industrial. We're talking about the Forest Service lands in the Sierra Nevada, which certainly are the largest owner of the lands in the Sierra Nevada. The center bar here in the center is actually telling us historic acres per year we think used to burn in the Sierra Nevada forest. And the different colors of the stack are the different forest types in the Sierra Nevada. Don't have to worry about that too much, okay? What we're saying here is about 500,000 acres used to burn annually in the Sierra Nevada before 1800, both indigenous burning and lightning fire, about 500,000 acres a year. The little bar to the left is actually what we're doing today. So this is basically the treatments that we're doing today. Relatively small, in fact, it's very small, okay? You're talking down here maybe less than 100,000 acres a year, excuse me. Over here now, if we think about this effort that's going on today, and we project that out about 25 years, of course, remember, we have to retreat these areas too. We can't just treat them once and then forget about them. So if we also put a retreatment frequency of about 20 years in there, so you treat an area, you come back 20 years later, you treat it again. If we use that and we use the current effort, this bar tells us what we call the backlog. This is the amount of forest, national forest lands in the Sierra Nevada that gets no treatment the next 25 years. It's just under 3 million acres. I call this a nightmare. This is a real problem. If you've got close to 3 million acres of the national forest of the Sierra Nevada going forward in a warming climate that's making fire more challenging, it's not the biggest issue. I would say our forest management and our legacy of our ecosystems is the biggest issue. Climate change is making it worse. And we're going forward with a 3 million acre area in the Sierra Nevada that is not adaptable to the future. This is a big deal. And this is why people all over the state and even federal government have been talking about this. Keith is the chair of the Board of Forestry. They've been talking about this a great deal. So I would just then maybe modify that original picture that I showed you a second ago, and I'd say fire lighters are our heroes, not just fire suppression, okay? So the lighters are also going to be our heroes someday, both indigenous cultures and us. And some of you are indigenous maybe in the call. So lighters are actually going to be also incredibly important. But I'd also say the need for restoration thinning is also profound. Restoration thinning using machines, at least in this state, from my discussions with a lot of folks on federal ground, is actually not desirable to a lot of people. I find that a little bit challenging. I think we got to use all the treatments we have to go forward and deal with this issue, including restoration thinning, prescribed fire, and other means. We've got some work to do. I'll just end here. Nathaniel Kenny, he asked us to imagine the future, didn't he? You know what the answer is? Fire back and restoration and working with the tribes. That's the mind-blowing answer. If you told that to Nathaniel Kenny in 1956, he'd probably fall over and get hurt. Because the idea that you're going to use fire proactively and actually do restoration thinning to work with the ecosystems versus just trying to suppress it all the time, that was a mind-blowing idea in the 56. And working with tribes is actually probably more mind-blowing because the tribes have been demarginalized for so long. What about some good signs? Well, there's an MOU that was signed by Governor Newsom and the Chief of the Forest Service just about 3 or 4 weeks ago. They commit to do 1 million acres a year restoration annually by 2020. Great idea. I think that's something that really we need to do, maybe even expand upon. Senator Feinstein put a bill into the U.S. Senate about 1.5 months ago that actually shows a lot of promise, trying to work with the wildland urban interface and also doing forest restoration. Senator Harris sent out a bill about the same time that really focuses almost exclusively on the wildland urban interface. I think it's a good idea, but I would also say we have a lot of work to do in the wildland areas. So I see all these efforts as being important, but I also say the next 1 to 2 decades is absolutely critical. I've been talking about this stuff for about 30 years, and I'm starting to get worried. You know, maybe I should get worried earlier, but I'm getting worried at just the impacts we're seeing today. So we're running out of time. We really need to move on this. And if we do move, I'm still hopeful, but it's time really to have a conversation with that land ethic that we need. So with that, I think I'm done, and I'll just leave it there. Thank you very much.
Scott, thanks for a great talk. It's always fascinating to hear you. You've got a lot of great questions that have been showing up, and some of them you anticipated. But I'll let you expand on one of those just a little bit if you want. the complexity of the question about what does fire like this do for wildlife habitat as it differentiates by species. I know that that study you had is the absolute touchstone for this. Go ahead.
No, that's a great question. And of course, their wildlife species have so much diversity, right? In terms of small mammals, to songbirds, to raptors, to things like the California spotted owl. So all of those are just incredibly diverse, right? And in our history, we've really focused on a few focal species. One of them is the California spotted owl, had tremendous discussion. Populations seem to be diminishing slightly, and people are wondering if it should be threatened and endangered by the U.S. Fish and Wildlife Service. Right now, it hasn't happened yet. And a lot of allicologists have worked on this species and said that they really seem to prefer nesting habitat that looks a lot like our controls. High density forest, lots of snags, lots of dead wood, maybe better for some of its prey species like the small mammals. But the challenge with that is that stuff sustainable into the future? There are also some really interesting studies now by some folks out of the University of Wisconsin-Madison, Zach Peary and others, that show that the owl actually prefers more of a mixed dynamic of forest conditions. Some open areas, maybe some areas a little bit thicker. Malcolm North has shown that it's actually the tall, big trees that they prefer versus just a bunch of small, medium-sized ones. So I think there's some complementary work there that can be done to conserve our wildlife species of concern and also conserve our forests into the future. One thing I would say, this idea that we can just put a line on the ground and just call that habitat for some species and just feel like we can maintain that in a climate change warming scenario in the Sierra Nevada, I think is basically impossible. So I just think we've got to work with these species and actually then try to work with the ecosystem.
So Scott, a couple of these questions really reflect a desire by some of the listeners to know where to get more information.
Mm-hmm.
So there are a lot of different portals into information. People are asking about burned area or where things were treated. As someone that's worked with a lot of these portals into the data that's available both on the historical record or the actions taking place, where would you point these people to for more information?
No, that's a great question, Keith, and also the people asking. We really do have a fantastic resource for this in California. CAL FIRE has something called the Fire Resource Assessment Program, FRAP. And CAL FIRE FRAP is one of the best repositories of things like areas treated, wildfire acreage, things of that nature. So a really, really robust group of people there. One thing that we've worked on right now, and I've almost completed it, we have a summary document for the entire surrogate study for the last 20 years. And we've written it really for people, media, policy advisors, and we're actually only about a week away from having it done. So when that thing is done, we're going to post it on our website and hope people might access it. It basically talks about all the research that we've done, summarizes the document. But I think CAL FIRE FRAP is one of the best places for some of the, like the treatment areas, things of that nature. And then maybe in a week or so, we're going to have this available. We'll put it on the Berkeley Forest website. The Berkeley Forest website will actually put that summary document of all of our 40 papers. It's probably about 15 pages long with a nice photographs.
Great. So Scott, it's very interesting here. Several people have sort of picked up on the difference between private lands and public lands in the state and the CEQA versus NEPA regulatory frameworks. Yeah. Could you make some comments on the difficulty of implementing the kind of management you're talking about on the private lands versus the public lands in the state?
No, thank you for that question. We have a colleague in the UC system, Ryan Tompkins. Ryan Tompkins is an area forest advisor up in Plumas County. And Ryan is actually also a person that worked at the Plumas National Forest for about 20 years. He recently stepped out of that capacity and moved into the University of California Extension System. So Ryan's done a really interesting analysis on the Plumas National Forest. And maybe you know the Plumas National Forest in the northern Sierra Nevada. This year we had a fire, 2 fires started by lightning, the same time in mid-August. The Bear Fire was one of them, and the Claremont Fire. Both of those eventually merged together and created a larger fire. But then in one particular evening, a very, very sad thing happened where tremendous east wind came and blew that fire all the way to Lake Oroville. Holy cow. burned through some really small communities, places that I've actually been through many years because I've taught at our forestry summer camp now for close to 25 years, Berry Creek and others. Tragically, human life was lost. So what's interesting about this is the Plumas National Forest has actually been planning landscape level fuel treatments for decades, and they've got people working at it. Ryan was one of them. So the Claremont had a Claremont project being planned for forest restoration right on top of the place where the Claremont wildfire ignited. Unfortunately, it never got implemented. The thing that's really telling about the NEPA process, and actually from the information that Ryan Tompkins is telling us, he documents 8 landscape level projects on the Plumas National Forest being planned for the last 20-25 years, and not a single one ever got implemented before a wildfire hit. 0 for 8. I'm not saying that's going to be the outcome everywhere, but Ryan makes the comment now, he thinks the NEPA process is not agile enough to actually deal with the issues at hand. It's too long, possibly too burdensome. On a private side, certainly much faster, quicker review. Board of Forestry, people in the state from CAL FIRE can actually do a review on a project and actually do a much more efficient job. And there's also even ways where landowners can actually work together and actually make a regional document. I think Keith even knows more about that. Maybe Keith, you could speak to that, please.
Oh, you're the star, but yes, the state is trying to take a higher level approach with something called the Vegetation Treatment Program Programmatic Environmental Impact Review process in order to allow bog standard sort of fuel treatments to proceed as if they're suitable for it, with more of a checklist approach than a full analysis. And so there are extreme differences here. So Scott, another question here talks about how easy is it to do burning? Yeah. And maybe you could talk about the difficulties there and the tension under the Clean Air Act with that little bandwidth of clean air we're all fighting for.
Oh, thank you for that question. That's an interesting one. And it is somewhat challenging to do the prescribed burning. You know, a couple of reasons is we don't have a lot of experience with it. You know, we have some experience, but we don't have a lot. And not having that experience, it just makes it a little more challenging. Let's jump to the other side of the country for a second. Prescribed fire capital of the United States of America is the Southeast US. Florida, Georgia, Alabama, South Carolina. Last year, the state of Florida prescribed burned 750,000 acres of forest, and Georgia did over 1 million. They've been doing this for about 50 years, so they have a program that's basically very mature. One thing about this maturity that's staggeringly interesting, about 5 years ago, a burn was happening in Florida on private ground, and actually is being done to try to enhance wildlife habitat. That fire unfortunately got away. It burned down 20 big houses. No one was injured, no one was killed, thank goodness. But the most incredible thing about this, we didn't even hear about it in the West Coast. Because what happened was people just said, we're gonna learn from this. We have actually liability insurance for the burners as long as they didn't do gross negligence. We're actually gonna take care of the people that lost their property. The governor didn't make a press release or somebody else and start pounding their fists on the ground saying heads are gonna roll. It just showed the maturity of that program to me. They're going to learn from it and go forward. California, we're starting that journey. One thing in the Feinstein bill, which I think is really interesting, is they have a prescribed fire training center inside Dianne Feinstein's bill to be located somewhere in the Western US. Tallahassee, Florida has had one for decades, and it's made a huge difference. So that training center could help us get a bigger workforce to do this work and actually start to do this work. You're going to write a prescription. Prescription is going to be based on the wind, the weather, also your expertise and your people, and air quality. You bring up air quality. 15, 20 years ago, air quality, even 10 years ago, was really a challenge to do prescribed burning. I'll be honest with you, the air quality agencies in this state have actually done a lot more work cooperatively with us. So I don't see them as a giant impediment anymore. It is actually a conversation that continues, but they're doing a lot better. So I think this idea of prescribed burning is something that I know we're trying to increase in this state. I applaud that effort. I do think we need more training. We need to do more of this capacity building for actually a workforce to do it. We don't have the workforce necessary yet, but I'm hopeful. I would estimate at least 10 years, 15 years to get a workforce up and operational in this state, because it would just, it's going to take time. We also need the social political institutions. If we have problems, and I guarantee we will, because I've had problems on my prescribed fires. I did about 150 in my career. If we have problems, inevitably, do we have the social and the political institutions in a state that enables us to actually learn from those and continue versus just trying to shut a program down? That's also going to be a challenge, but I still believe I'm hopeful on that topic.
It's great. And Scott, as I'm sure you're well aware, Florida addressed that issue of the liability for the use of fire more than 30 years ago in a way that we haven't in some other states. Someone has asked, and I think this is a great question for you, given the breadth of your experience internationally. What are the lessons from around the world that you see could inform better practice in California?
No, that's a great question. You know, one place I spent a fair amount of time is Australia. You know, I've had the pleasure of being there for 2 sabbaticals. The last one was in Western Australia. So that's Perth, you know, out there in the west side of the continent. And Western Australia and Southern Australia, extreme Southern Australia, is a Mediterranean climate. So it's just like us, except their summer is Christmas, right? So it's just a little different phase. But that particular area has the largest prescribed fire program in a Mediterranean climate in the world. And they've been working at it also for decades and decades. Rick Sneejak is actually a former head of that entire program, and I was fortunate to get to know Rick pretty good. So Rick would say a couple of things. He came here about 15 years ago to have this very conversation. You know, he said, okay, Scott, let's take a look at your landscape. Well, one thing we know, just like we talked about, we got to train a workforce. Got to train that workforce. We don't have it yet, but we can do that through activities like a training center and getting people both federal, state, private, and actually certified. Then he said, you got to work with your political institutions. He said that every time there was a new governor or premier of Western Australia, he would actually bring them out, the entire staff, on multiple prescribed fires just to get them familiar with how they did the work, what the challenges were, and what the successes were. So he constantly had that dynamic of really the political system. And then the last thing he said, this is one that's a little telling to us, is, Scott, you're going to start with a landscape that's very challenging. We don't have a lot of mosaics of our vegetation and fuel like they have in Western Australia or the Southeast, where they've been burning for 40 years. We can use those as anchor points to start a new fire from. We can run a fire at one of those signs and actually anticipate it's going to go to the ground. So Rick says, well, you're going to start with a really difficult landscape situation. So you've just got to go at it, maybe work next to wildfires. Use the wildfires as actually some of your anchor points to burn away from. So the Western Australian experience does explain that it can happen. And actually, people then get more culturally aware of fire. In the Southeast one time, I'll just make a quick mention. I was in a parking lot, I think for a Walmart a few years ago. And right on the edge of the parking lot, prescribed fire was happening. They were burning some forest areas. And I was just standing there looking around, and all people were doing was they're getting out in the parking lot, running to their cars to get out of the smoke. Nobody got on their cell phone. No one was taking pictures. It was just a fact of life. You know, isn't that extraordinary? The idea that you can burn next to a shopping center in Florida and don't cause a ruckus. So it just shows us, again, the cultural aspects of how to get this work done.
You know, Scott, we could, with the questions I have in this document I'm reading right now from the audience, we could go on for hours. But perhaps we could just close on a question that deals with a thread that I see throughout this, which is about people and the wildlands. Yeah. And, you know, I'm sure you understand the question that's being posed here in terms of why are we in the wildlands? What should we be doing that? What is our social response? What are your thoughts about living in harmony with the wildfire risks, which are inherent to much of California?
No, that is really a really important question, you know, because just like you say, you know, we really live in places that are fire prone. And of course, this has been happening for decades and decades. And we see more and more people being adversely impacted by fire in these communities. I think there's 2 things. I think there are 2 fundamental things to the fire issue in the state. The first thing is to get our human communities better prepared for inevitability of fire. We got to get people better prepared. And that means small rural communities. It means individual groups of landowners. Get them prepared to actually work together, come up with a plan. You know, the plan could be, well, we're going to do some vegetation management over here near this canyon because we think a fire might come out of there someday. The plan might be, well, let's work together to try to get maybe a contractor up here to help us understand what we can do to our buildings with better materials so we can have less prone ignitions around our house. What can we do with our vegetation near our home? How can we reduce the vulnerability? How about a plan for evacuation? How about we got a neighbor that's actually 88 years old with no car, and when a fire comes, 2 of us are actually going to make sure that she gets out. So I think there's so much to be done with the scale of small communities. In Australia, they call them community fire brigades, where people get together and they volunteer to make a plan for the community. And they ask the professional fire service to come in and work with them, and the professional fire service is happy to do it. University of California Cooperative Extension could do this. Man, that's a muscle. The cooperative extension has been used for decades on agriculture. It's made agriculture success partly in this state. We could do the same thing with fire, get a cooperative extension program in fire. The other thing you got to do, the fundamental number 2, is work in the wildlands. You've got to get the wildlands more apt to deal with fire, not generating flames that are 100 feet long, throwing embers 4 miles ahead that come right down on top of houses. So the fundamentals are working with communities to get them better prepared and work with them, maybe with a cooperative extension group or even a local group, get them better prepared, and also work in the wildlands to make them more resilient to climate change, fire, and insects and drought in the future.
Excellent, Scott. Thank you so much for your presentation and for everything you're doing on the policy front and the science of increasing our knowledge about how to live in harmony with fire and protect the environment we all hold so dear. I'm sorry we didn't get to all the great questions that were posed, but I hope that everyone that was tuned in and listening enjoys some of the other activities associated with homecoming today. Thank you, Scott.
Thank you very much. I appreciate the great questions. Thank you, Keith.